Welcome! Today, we're going to dive into one of the coolest and most powerful ideas in all of math, complex numbers. Now, I know they might sound a little intimidating, but trust me, their story starts with a really simple problem that seemed totally impossible to solve. You know, the great mathematician John von Neumann said this, and it really is the perfect way to kick things off. Complex numbers can feel a little weird at first, maybe a bit strange, but once you get the hang of them, they unlock a whole new way of looking at the world. So where do complex numbers even come from? Well, it all starts with a very basic question. What do you do when you hit a wall? When you have a problem that seems to have no solution using the rules you've always known? Well, you invent new rules.
To really get why we needed these new numbers, we first have to see where our familiar, everyday numbers fall short. So let's take a look at a specific problem that our good old number line just can't handle.
Okay, here it is. It looks pretty harmless, right? I mean, if we just move that one over to the other side, we're looking for a number, x, where x squared equals -1. Simple enough.
And here's where we hit a brick wall. Just think about it. Take any number you can think of, positive or negative, and square it. 2 squared is 4. -2 squared is also 4. You always get a positive answer. There is simply no real number out there that when you multiply it by itself gives you -1. The problem is impossible. Or is it? For centuries, this was just a dead end, a mathematical curiosity. But instead of just giving up, some brilliant mathematicians took an incredible creative leap of faith. They decided that if a solution didn't exist in the real world, well, they'd just have to invent one.
They basically just said, what if we create a solution? So they did. They invented a new number, they called it I, for imaginary unit, and they just defined it as the square root of -1. It doesn't live on the number line. It's a pure concept created just to solve this one nagging problem. And with that one new piece, I, a whole new universe of numbers was born. Complex numbers. Every complex number, which we usually call z, is just a combination of a familiar real part and this brand new imaginary part. So here's the key takeaway. A complex number is like a two-part deal. You've got the real part A, that's just a regular number we already know and love. Then you have the imaginary part B, which just tells you how many of that new imaginary unit I you've got mixed in.
Okay, so wait a second. If every complex number has two parts, a real one and an imaginary one, where do we even put it? A single number line isn't going to cut it anymore. And this is where the visualization gets really, really cool. We need to add a whole new dimension.
I mean, think about it. The classic number line we all learned is just one-dimensional. It goes left and right, and it covers all the real numbers. But where in the world would you put a number like 3 plus 2i? It needs another direction to go. And the solution is just beautiful. We keep our horizontal number line, and we call it the real axis. But then we add a second number line running straight up and down through 0. And we call that one the imaginary axis. Put them together, and voila, you get the complex plane. All of a sudden, every single complex number, a plus ib, has a unique address on this two-dimensional map. You just go a units along the real axis, and b units up or down the imaginary axis, and there's its home. Okay, so we've built this amazing new two-dimensional world for our numbers. So what can we actually do in it? How do we use them? Well, let's see how something as simple as adding them together works in this new plane. Visually, this is super intuitive. You can just think of each complex number as an arrow or a vector pointing from the center of the plane out to its spot. Now, if you want to add two of them together, you just place the arrows head to tail, line them up. The answer is just the new arrow that stretches from the very beginning to the very end. And the math behind that cool visual? It's beautifully simple. To add two complex numbers, you just add the real parts together, and then you add the imaginary parts together. You keep them separate. Each dimension just handles its own business. Simple as that. Right about now, you might be thinking, okay, this is a fun new system, a clever game for math nerds, but is it just a game? Absolutely not. This imaginary leap turned out to have incredibly real consequences, and it literally changed science and engineering forever. What we get is, first of all, a number system that's finally complete, a place where every polynomial equation has a solution. But beyond the pure math, this idea of an imaginary number became the perfect language to describe the real world, from the AC electricity flowing through your walls to the weird and wonderful fabric of reality and quantum mechanics. And here's a great little detail that really shows how practical these numbers are.
Electrical engineers use complex numbers constantly. The thing is, they already used the letter I to mean electrical current. So, to avoid any mix-ups, they just call the imaginary unit J instead. It's the same idea, just with a different name tag. Problem solved.
So, in the end, that incredible leap of imagination wasn't just about solving one little equation. It was about building a richer, more complete framework that actually let us describe the real world in ways we never could before. It kind of makes you wonder, doesn't it? What other impossible problems are out there right now, just waiting for someone to imagine a new solution?